Hello everyone, I hope you're all doing well. My name is John, and in this video I'm going to be going over some more of the analytics tasks within Gaio. So things like the sample, AutoML, scoring, cluster, and forecast tasks. I have this sample application pulled up, and in this flow here I am actually calculating churn. So if you are unaware of what churn is, it's basically just the rate at which customers leave or become inactive on your platform, maybe stop paying for your service or buying products from you, things like that. It's a relatively important analytic for your business, for your company to know in order to be able to maybe better keep users on your platform, spending money with you, things like that. Obviously, this is just a sample here, not based on real data or anything. And the first task that we use in this flow that I want to go over is the sample task. And the main use of this task is actually to take a sample from your dataset or one of your tables. So, you might have 50 million rows, 700 million rows, something like that. You might have a lot of data, and running calculations on every single row or training a machine learning model with every single row can be, very resource intensive. So the sample task allows you to just take a sample from your data, so you don't need to use every row for every calculation every time. Just in the situations where maybe you don't need to do that for every single row or every single piece of data. But here, there's not a whole lot of options. Just naming the task, naming the result table. You can see that here, sample churn analysis. The type is just whether you want to calculate the sample based on percentage or number of rows. So maybe you only want 50% of your total rows, or you can maybe say, oh, actually I want 5,000 rows instead of a percentage, whichever one works for you. Here I'm just taking 50%, and I'm just going to save and run this task. And as you can see, I started here with 5,827 rows, and my sample table only has 2,914. The next task I want to go over is a really cool one. This is the AutoML task. I have one here already, but I think I'm going to just set it up again for you. So just going to select the AutoML task. Nice. And what this task does is it basically allows you to create and train a machine learning model based on your existing dataset to solve or predict the outcome of a particular column. So in this case, we're calculating churn. So, we have a column for customer status, whether they're active or inactive on our platform. So what we can do is train a machine learning model based on most or all of the columns and rows in our existing dataset to then predict in the future whether our existing customers will become inactive or if they will stay active. So here you're able to name the model. Maybe you're calculating churn here, but you have some kind of other machine learning calculation going on other in your application. You can name this differently so you don't get confused when you do end up applying that. The table is just where the table that you're training the machine learning model on. The target column is the column that you want the machine learning model to solve for. I believe in this table it's called customer status. Yep. And this column just has two values, active and inactive. The columns I want to remove are things like IDs, columns that you don't believe would be helpful for the machine learning model to be pulling data from. We as humans understand that the ID is not deterministic of whether or not a user is going to be active or inactive, but the machine learning model doesn't know that. So by removing these columns. We're not going to confuse it. We're not going to give it more information than it needs. And next we have the row limit. So basically, because machine learning model training can be very resource intensive, it's good to maybe not include all the rows if you have a table of 20 million, like I was explaining. And maybe better to keep it a number like 100,000, 500,000, something like that. So here we can just set the limit. Obviously our table doesn't have anywhere near this many rows. And at the bottom, we can create tables for the metrics and statistics. So once I have saved and trained the model, we'll have some options over here that let us kind of go into the different models it tested, what variables it thinks are more significant, things like that. And just with this option here, we can actually have Gaio create tables instead of just having to go into the ML task to see that information. And we're able to define a suffix, so I think I'm just going to do AutoML demo. And now we can save and train our model. As you can see, this cool graphic shows up while it's training, and we only set the training time to 30 seconds, so shouldn't be too long here. And now the training is complete. You can see that now we have some of these new options here on the side. The summary just shows variables and relative importance, as well as the accuracy of the best model that it found. So you can see last purchase, days between last purchase, order date month, average ticket customer, and customer tenure are all the most important columns or variables we have in our data to determine whether or not a customer is going to become inactive or not. We can go into the models tab here, and this will just show us the different models that it tested and basically the accuracy of those models, with the most accurate one being number 1, the one that it usually picks by default. And we have our cross-validation table, a confusion matrix that is able to show us how accurate the predictions of the model were. We have our gain table and our maximum metrics. Now I'm just going to click save, and because we had that table option selected, it actually created all of those as tables. So let me just select all of these and move them just over here so they're not in the way of anything. But yeah, basically these tables just have the same type of information that was in those tabs, but now it's in a table. So maybe you need to use it for your data, or you want to output maybe the values into a dashboard. Maybe your end business user wants to see how kind of accurate the model is, or something like that. You can certainly do that with these tables. So now that we have a trained machine learning model, what are some of the things we can do with that? So one of the main things we can do is actually use the scoring task. So if I go into this, I believe it's in the churn dashboard. Yep, we have a scoring task here. So we have our sales e-commerce table. So this is the one, without the sample, no changes. And we are going to use the scoring task. So let me just open this real quick. Obviously we can give it a label. We can name the result table and choose the source table as well. And here, actually, we're able to choose the model based on ones that we have already trained in this application. So I have one for customer profile, and obviously the 2 for churn analysis. You can identify these using the ID, so I'm just going to select this one and save. And now if I run this task, if I go into the result table, you can see that it has a prediction, and then it has the precise score it gives for both options for every customer ID. So if I just make this a little bit bigger, we can see here for Jonathan Lloyd that the active score was a little bit higher than the inactive score, so it predicts that this customer is active. A little bit of a different story for Christian Watson. It's predicting that it's inactive. And you can just go through and see kind of the maybe specific customers that it predicts to be inactive or active. And these scores here really help you kind of maybe help determine maybe the decision-making process for the machine learning model, and maybe which scores are closer. Maybe you exclude those from your eventual table, because in Gaio, now that we have this scoring calculated, maybe you want to send a promotion or a sale to users you think might become inactive soon, or things like that, but you don't want to give it to everybody, right? So maybe just choosing the inactive scores that are the highest, or things like that. So you can use all three of these columns, or just one, or things like that, and get creative with how you want to use this information now that you have it. And in this case, we're just using it for a dashboard. So navigating into the order analysis process, I can show off the next type of task, which is the forecast task. And you can see here, we're taking our sales e-commerce table, which has things like order, customer ID, customer information, order information we might need. We're tailoring it down to a couple less columns, just the order date, month, the product category, and the sum of the order quantity. And we're doing this group by just to allow the sum to occur, which gives us this table, the temporary order demand table, which we're feeding into the forecast task. So to get into the forecast, what this task does is it uses time series to forecast or create predictions for certain values as they move into the future. So specifically with this table in this example that we're using, we're trying to forecast demand. So if you remember from the table before, we are only taking the item quantity. So we're not forecasting sales numbers, just demand of the amount of items that might be sold in the future. So here we have a task label that we've called forecast demand, the result table, forecast order demand here at the bottom, and it actually creates another result table called the metrics table, which just basically shows some of the statistical variables that are being used and their actual values. So if you're more familiar with doing this kind of analysis, these kinds of calculations, you can determine how significant those forecast numbers will be and how close they might be to reality. You have to put in some kind of date column, just so the algorithm understands, what's past and what's future. A measure, in this case, we're using some order quantity, so the number of items. But this could be, your sales numbers or any other number that you might be trying to predict for the future. We select our frequency, so this can be monthly, daily, or weekly, and the number of periods we want to predict. So because we've chosen monthly, we are going to predict 6 months into the future with one value per month. And we have this additional classification here, so we are going to later analyze the forecast by product category. So we're just going to add this here to make the distinction between different categories of products. And we can just click save. And I'm just going to run this task. And now that it is completed, let's check out our result tables, starting with the metrics table. I'm not going to go so in depth here, but here you can see you have the category, the MSE, RMSE, R squared, all of that kind of information. But what I really want to focus on is this forecast order demand table. So you can see that for every category, it's creating a value for every month, including the 6 months into the future that we want to predict. And it has changed our date column into DT. We have this real column. So basically this type column will say either forecast or real meaning it's a real number that we got from our table. But even with the real numbers, there's a forecast with a lower and upper limit. But where the type is forecast, maybe I can find that. See here for toys, because we have no orders yet for July, the type is forecast. There is no value for the real because there isn't a real value yet, but there is our forecast number and lower and upper limits. And these limits just let you kind of give a full range. Maybe you're making decisions about how many materials to buy or how many items to produce, things like that. Just having a larger amount of numbers in front of you helps you better make educated decisions on some of those things if you were using these analytics to kind of inform some of your upcoming decisions. But another really cool thing about the forecast task is actually in Gaio we have a special type of report that can display your forecast. So if I go into my forecast demand dashboard, we have them split into categories, but I could just open fitness just as an example. And if I go into the type, you can see that this is actually a forecast type. And it will require a table that's basically the output table from our forecast task, so that it can do stuff like create this orange area here where it's mapped the line itself with the forecast numbers, and it's created this area for upper and lower limits. But the cool thing also here is you can see the forecast line for months that have passed, and our real number in comparison as well. And now that might just help you from a visual standpoint understand, hey, it's starting to get more accurate predictions, or hey, this month we exceeded the expectations of what might have been statistically probable. So it lets you even analyze your past months as well. But yeah, let me open maybe another category 2 just to show you as well. So for toys here, we also have this predicted area, and the graph looks pretty similar. But yeah, it just displays all of the relevant information based on the forecast, and I think it's really cool. Now, finally, the last task we're going to talk about in this video is the cluster task. You can see that here. And basically what the cluster task does is it will take your data set and create categories based on types of customers or information. Maybe you have, I guess I could stick with customers. So maybe it'll cluster by all of the information. It won't necessarily give you an output in text about what the quote unquote categories are, but it will probably generally cluster your customers based on things like age, location, how many purchases they made. It's really limited to what types of data you have. So let me open this customer profile prep 6 table just to show you some of the columns that we have here. So customer name, gender, age, city and country. We've done a little bit of RFM analysis here, which won't be relevant. The tenure, average order, and things like this. Some of the columns we've actually used before, but just formatted like this. So what our clustering is going to do, if I open this task, is it's going to take all of that information and put our customers into a certain number of categories. Now you can set that here or let it be automatic. Based on all of that criteria, it's going to do its best to find trends in the measures based on certain categories, based on certain column values, and put those customers into categories. So here we're naming it customer profile. We have this customer cluster, customer profile output table. We are excluding the customer ID and RFM columns because similar with the AutoML task, we don't want to confuse the algorithm at all with information that it doesn't really need. And RFM is another way to actually classify customers. So we don't necessarily want this to be included because this is a different type of classification analysis. We can have our execution time. You can set a max cluster size or set it to automatic. I'm just going to set it to automatic, see how many clusters it creates. And let's go ahead and run this. Now that it's run, if I open the table, you could see that all the way on the right, we have this new column, predict. And if I open it here, you can see that there's values of 0, 1, 2, and 3. So it looks like the task created 4 different categories of our customers, which will let us kind of maybe easier understand their behavior. Now that we have specific categories, maybe these people will respond to certain types of incentives or certain products differently, and we can individually analyze their behaviors to maybe understand some more of the trends that it found, and things like that. So it's very interesting to be able to use the cluster task to find some of that stuff. And once you've clustered as well, you can use that information in AutoML or things like that, just because now that's more information that you can give the machine learning algorithm, because maybe you have a higher percentage of inactive customers in category 2 or something like that, and it might be able to spot that before any kind of human might be able to understand that relationship. But I think that concludes this video. If you do have any more questions, our documentation will be linked below. And as always, our customer support team is always willing to answer any of the questions you may have. Thank you so much.